Howdy. This is the chapter 24, video 4. We are going to look at the reactions at alkylamines. The first reaction is alkylation. If we treat the primary amine with the excess of alkyl halide, we saw these reactions in the previous video. The hydrogen from this halogen leave and form a secondary amine. If we react it with alkyl halide, the same thing happens, it forms a tertiary amine. And tertiary amine reacts with alkyl halide and forms a quadriammonium salt. So it keeps reacting and form a mixture of products. The second reaction we are going to look at is acylation. What is acylation? Adding acyl group. Look at these two compounds. This is an acid chloride. This is an anhydride. The group in the box is called the acyl group. We can shortly write it as AC. So we can call this compound ACCl, this anhydride as ACOAC. These are acylating reagents. They add acyl group to the amines. But they acylated primary and secondary amine. You have examples here. This is primary amine. You can treat it with acid chloride or anhydride, any one of them. A hydrogen, this leaving group goes away, and this forms an AC group. The hydrogen is there. So this is nothing but this is AC group is this group. Instead of writing this group, we write AC. If you react the secondary amine with one of the two, the hydrogen, if you treat it with this goes away, and then it takes the AC group. The acyl group replaces a hydrogen. So these reactions are called the acylation reactions. Tertiary amine contains no hydrogen, so it will not undergo acylation. There is another important reaction we are going to see. I put 3 stars there. It is called a Hofmann elimination. This occurs at the primary amine, secondary amine, tertiary amine. What is this reaction? If you look at any amine, primary or secondary or tertiary, this is not a leaving group. So we cannot substitute it, or we cannot do some reactions. But if we convert that into actually quadriammonium salt, this is a good leaving group. So we are going to do that in this one. In the primary amines, this is a mechanism. It's a primary amine. You treat it with excess of methylaldehyde. Methylaldehyde is an alkyl halide. If we treat it with excess of alkyl halide, it replaces 2 hydrogens and also replaces the lone pair. It forms a quaternary ammonium salt. We are going to treat that with the silver oxide and water mixture. We call that as moist silver oxide. This is a paste. You take a silver oxide powder and put some water and mix it into a paste. They react together and form this silver hydroxide. So silver hydroxide, the silver takes the iodine, this iodide group, and the OH replaces it. OH is a good leaving group. Sorry, OH is a good base. This and nitrogen is a good leaving group now. You have an alpha and beta carbon. Beta carbon has two hydrogen. Let me highlight one. You know the elimination process. The base subtracts a proton from the beta and flip the bond and they help the leaving group to leave. So what do you get now? You get an alkene. The alkyl group in the primary amine becomes alkene. What is the other product? It is also an organic product. It is a tertiary amine. So this is called the elimination. Since it is invented or discovered by Hofmann, it is called a Hofmann elimination. I'm going to repeat this mechanism with a secondary and tertiary amine. This is a secondary amine. Same thing if you treat it with excess of ammonia, the methyl group there replaces this hydrogen and also adds here, form the quadriammonium salt. And you treat it with the silver oxide, it makes this iodine as a silver iodide and the OH. But in this case, two alkyl groups contains beta carbons. Both beta carbons contains hydrogens, where the hydroxide will pick up the proton, abstract the proton. From here or from here. This has 3 protons. Because this goes to the less subtracted beta carbon, less crowded, because already there is a crowd here. So this will go here and flip this bond. What do you get now? You get this amine. And what is your alkene? This becomes a double bond. This is an alkene. So which group actually becomes an alkene? The one which contains less crowded beta carbon becomes an alkene. This is, you see, this is an alkene. If you go to the tertiary amine, this is the tertiary. Already it has 3 alkyl groups. If you treat it with excess of methyl iodide, it replaces one. So this is the quadriammonium salt. And silver oxide, it becomes silver hydroxide. In this case, there are 3 groups contain beta hydrogen, alpha, beta. This is alpha, this is beta, alpha, beta. Which one contains less hindered beta carbon? This one. So I'll put it here. So this goes here and flip the bond and flip this bond. Because this has an alkyl group, this has an ethyl group beta, they are crowded. So you get this alkyl One CH2, this is a CH2. Double bond CH2 plus your amine, you say. So in this case, the alkyl group that contains a less crowded beta carbon, that is this one, becomes an alkene. These reactions are all carbon eliminations. We eliminate amine from these compounds. So problems here. I have a secondary amine. So in this case, this is an alpha, this is beta. This side, this is an alpha, this is beta. So this side of beta contains less crowded. So this will actually become alkene. Remember that way, less crowded. So the best way to do it is a secondary amine, react with it, replace the methyl with hydrogen with the methyl, and add one more methyl, make it positive. Now, if you break it, this will have a lone pair, and this comes in, this becomes a double bond. Since it is a ring compound, when it breaks, the alkene and amine stays in the molecule. So in this case also, NH2 is a primary. Simply make it as actually quadrammonium salt. And then take the hydrogen from the beta. This is an alpha, flip it and kick it out. It will help you to write the other product this way. This case also, it is a primary amine. So methyl iodide replaces these two hydrogens and also adds to the lone pair. And then in this case, this is an alpha, this side beta, this side beta. This beta is less crowded. So you take the hydrogen from it and then flip the bond and kick this out. So this is going to be, don't forget this methyl group. And you get the other product, that trimethylamine. That's the way you have to write the products. Pretty simple. It's a short video.